To factor a number means to write it as a product of two or more integers. You already know many factorizations from your basic multiplication facts, such as 48 is equal to 6 times 8. A factor is a number that appears in a factorization, so that we would say 6 and 8 are factors of 48. Example, find all possible factorizations of 24 into a product of two numbers. This process is very similar to finding divisors of a number. In fact, every divisor of a number is a factor in some factorization. It is best to work systematically, just as we did in the previous section. This will help you to avoid skipping values and making other errors. We will start with small numbers and work our way up. 24 is equal to 1 times 24. It will always be possible to factorize a number using 1 times itself. Is 24 equal to 2 times something? Yes, 24 is 2 times 12, so that is our next factorization. Is 24 3 times something? 3 times 8. Is 24 4 times something? 4 times 6. Is 5 times something 24? There is no integer that you can multiply by 5 to get 24. And then we see that 6 is already listed in one of our factorizations, so this is how we know that we're done. In the last section, we introduced the idea of a prime number. A prime number is a number that has exactly two divisors, namely 1 in itself. The primes represent the most basic numbers that we use in multiplication because they cannot be broken down any further. When we write a number as a product of primes, we call it the prime factorization of the number. Example, find the prime factorization of 24. The factoring process begins by factoring 24 into a product of smaller numbers. Then we factor those numbers if we can, and continue onward until we're left with primes. We will organize this information using a factoring tree. The factoring tree must be included in your presentation. There are many ways to start, but we will start by factoring 24 as 4 times 6. And we will now look at the numbers at the end of the branches to see whether we can factor them any further. The number 4 can be factored into 2 times 2. And the number 6 can be factored into 2 times 3. And we just repeat this process. We will look at these numbers and see whether they factor. 2 is prime, and 3 is prime, so we cannot factor these any further. This gives us our prime factorization. We will write the prime factorization in the following manner. 24 is equal to 2 to the third power times 3. This notation is known as an exponent, and it represents repeated multiplication. When we write 2 to the third power, this means 2 multiplied by itself 3 times, or 2 times 2 times 2. The small 3 written above and to the right of the 2 is called an exponent. The normal size number is known as the base of the exponent. The base of the exponent is the number that's multiplied by itself, and the exponent tells you how many times it is multiplied by itself. An interesting fact about prime factorizations is that you will always get the same prime factorization no matter what order you factor it in. We can see that in each of these factoring trees, if we go to the ends of all the branches, we have 3 2s and 1 3. This means that all of these factorizations will end up being 2 to the third power times 3. When writing out the prime factorization, it's best to have the primes in increasing order. This just makes it easier to compare answers with other students or the solutions in the book. Example, find the prime factorization of 36. We will start out the factorization by using 4 times 9. Is it possible to factor 4 any further? Yes, 4 factors into 2 times 2. Is it possible to factor 9 any further? 9 factors into 3 times 3. The numbers 2 and 3 are both primes, so these branches all stop here. And this gives us our final factorization. 36 is equal to 2 to the second power times 3 to the second power. Some exponents have a special way of saying them. For example, 4 to the second power can also be read as 4 squared, and 4 to the third power can be read as 4 cubed. The words squared and cubed refer to the geometric figures, and they correspond to the number of dimensions. A square is in 2 dimensions, and a cube is in 3 dimensions. Example, find the prime factorization of 11. Sometimes students panic when something new or different happens. Just stop and think for a moment. After trying a few times, you should realize that 11 is prime. This means you can't factor it any further, and it is its own prime factorization. In other words, the tree has no branches. If you feel strange writing 11 is equal to 11, you can also write 11 is prime. Either answer is acceptable.